Good day, boys and girls. Today we'll be looking at technical mathematics. Now, under technical mathematics, the topic that we are going to be doing today is circles, angles, and angular movement, right? By the way, my name is Mr. Posa. Then before we can start our lesson for today, I just want to advise grade 12 learners about the document that they should have, which is the examination guideline for technical mathematics. Is very important, particularly for this topic that we are going to be doing today. So please go and get that document. You can get it from the DBE website. Just type from Google, just type examination guideline for technical mathematics. All right, now let's proceed and see what we are going to get on our topic for today. Now, under content, we are going to be dealing with circles, angles, and angular movement. Now, under this topic, we have got subtopic, which is angles and arcs. Then we move to degrees and radians, where we are going to convert degrees to radians, or we convert radians to degrees. Then we move to sectors and segments. And the last one that we will be doing is angular and so they sometimes call it velocity. Okay, so those are the subtopics that we are going to be dealing with today's lesson. Now let's see what we are having. First is in degrees and radians. But how do we do that? It says we can measure angles in degrees or radians. A radian is a measure of an angle that, let me just have a pen here, that indicates the relationship between the arc lengths of a circle. Converting between degrees and radians. We are now going to be learning on how do we convert this degree and to radians, vice versa, the radians to degrees. Now the size of the central angle, which is theta, you can see theta is found by dividing the arc length. We're having an arc length which is S, right, by the radius length which is R. Now we can see that the formula that we're having here is theta is equals to S, which is the length of arc, divided by R, which is the length of radius. So if, for instance, you want to calculate the central angle between the two given radii, then you are going to use this formula, which is theta is equals to S over R. Then remember, S is the length, is what? Is the length of arc. Now in this case, you can see from the picture there, this line here, this arc, you can see this arc here, that's this arc, we are calling it a length of an arc, which is represented by what? By S, right? So they can sometimes ask you to determine the length of this arc, which is S, right? And then we also have what? The length of the radius. You can see we've got two radii, which is this one, the first radius, and the second radius is this one. So we call them radii because they are two. Okay. Then we also have angle in between, the angle theta there, right? We also have the angle theta there. Now, every time when we calculating this type of a question, make sure that you always convert degrees to radian, because in this case, we are we are going to be calculating using the radians, right? So please bear in mind that every time when you are dealing with what? With degree, we always convert that degree to radians. But how do you convert it? Now, first we say to convert degrees to radians. To decrease to radians, multiply degrees by what? By pi over 180 degrees. If you want to convert radian to degrees, then you are going to multiply I hope it's quite simple for you, my dear learners, that if you move from degrees to radians, you multiply by pi over 1/8, right? Then radians to degrees, you multiply by what? 180 over pi. So that's how it's easy. It's very simple on how to convert degrees to radians or radians to degrees. Very simple. You just have to understand which fraction are you going to multiply with. Now let's proceed. Then we are having example where we are going to convert radians and we're going to also to convert what? Degrees. Now let's see the question that we might get, right? The first question, it says, convert 2 radians. Now we're having a 2 radians to degrees. We want to know a 2 radians in terms of degrees. It's going to be how much, right? So then we're going to use the calculations and see how do we calculate that. Now we have 2 radians. Then you're going to say 2 radians multiplied by what? 180. 180 divided by pi. Then the answer that we're going to get is this one. Remember, we are converting radians to degrees. The answer that we're getting is 114,592 degrees. All right? The second question, we should now convert degrees. We are converting now degrees to radians. Degrees to radians. Now, when you convert degrees to radians, you're going to write your degrees as is shown on the screen is 225 multiplied by what? Pi over 180. All right? Then you just press your calculator. Then our answer, it is in terms of what? Radians, right? It is in terms of radians. Now that's how you should convert radians together with degrees, right? Now let's proceed. Calculating the area of a circle sector. We are now going to be focusing on how do we calculate area of a sector, right? Now first, they are saying sector of a circle. A sector is the, let me just show a picture there. And then a sector is a region of a circle enclosed by 2 radii, meaning you can see from the picture what is the sector there. So it's this shaded part. So that part we call it a sector, right? Now, and angle or an arc of a circle, a sector can also be referred to as a way or a slice. The 2 radii divide the circle into 2 sectors called the major sector and the minor sector. Now you can see from the screen which one is the major. This is the major, meaning the major is the bigger one, the bigger sector, and the minor sector is the smaller one, the slice. Can you see the slice? Yes. Now, the formula for the area of the sector of the circle is, now let us get the formula that we are going to use in order for us to calculate what? The area of a sector. Now, that formula it says 1/2 equals to r squared theta, right? Now we all know that this r stands for what? This r is what? Is radius, right? That is going to be radius, and theta is our angle. Meaning when you have to calculate the area of a sector, then you're going to use this formula that says 1/2 r squared times pi. No, really, sorry, times theta, right? Then, or you can use this formula that says area of a circle sector equals to r multiplied by s/2. But how is these people move from this to this one now? How did they obtain this one? Now, if you remember the previous slide that we dealt with, where we were talking about how do we calculate theta there, we said theta is equals to what? Is equals to S, let me just try to write it, S over what? Over R, right? Now, when you have to make, now if you just do what, where you see theta, you substitute with this S over R, then you're going to obtain what? We're going to obtain this R multiplied by S over 2, right? Where you see theta, you substitute with what? S over R. Then you're going to get what? R multiplied by S over 2. All right? Remember what is S? S is the length of that arc, right? It's the arc length. This is the arc length. This is S. Let me just show you this portion here, or this arc here. That's what we are talking about S. So it's arc length, right? So if they ask you to calculate arc length, don't forget to use this formula here. Then it's very clear, just underneath these two formula, where S is arc length, we know that, and the R is radius, and then theta is what? Is central angle in radians. Let me underline this, in radians. I also indicated that every time when you get a question, and this question, it is in terms of degrees, please convert it to radians, because we always work with what? Radians. But now, since we have learned on how do we convert degrees to radians, then it's going to be easy for us to just change degrees to radians, all right? And then when they talk about the central angle, remember they're talking about this angle here, this angle here, the angle between the two radii, right? That angle between the two radii is the angle that we're going to be dealing with. Now let's proceed. Now we're having example for sector on how do we calculate. The first question says, show that the area of a shaded part, the area of a shaded sector, I mean, the area of a shaded sector is 231 meters squared, right? Meaning we are talking about this part. We are talking about this portion, this part, right? So we want to know the area of that sector. So we are going to prove it, whether it's going to be what? 231 meters squared. Then how do we calculate it? Let me just remove this so that we can see our angle there. Now our angle, you can see it's 135 degrees, right? Then remember earlier on I said, if it is in terms of degrees, then you have to do what? Converting there. Now, from the solution, it is very clear that we have to convert what? To convert 135 degrees to radians first, before you can calculate the area of the shaded sector, or the area of the sector. you have to convert first. Now let's convert, because we have learned to convert degrees to radians. Then this is the formula that we're going to use. And then you just press your calculator. Then our degree, or our theta, pardon, our theta is what? Is in terms of radians, and that is 3 pi over 4. Now we can be able to calculate what? The area of the sector. Now you write the formula. You remember the formula for the area of a circle sector is 1/2 theta multiplied by r squared, right? Then we have to know our theta. Remember our theta, we have it, which is this one of 3 pi over 4. And then we have what? R. What is our R? The radius. What is our radius? In this case, we can see our radius is 14 meter. Our radius is 14 meter. Then the second step, we are going to substitute our theta and radius, and then you just press your calculator. Yes, we have just shown that the answer for area of a sector is equals to 231 meter squared. So our calculation is very correct. Now we can proceed. Now we are having a second question. Let's see what we are having in this one. All right. Number 2, it says, determine the area of a minor sector. Let me just underline minor. Remember, we talked about minor and the major. Now the minor is the smaller one. Can you see that? This white, it's shaded in white color there. So that is the area that we are going to be calculating. And then leave your answer in pi form, right? Leave your answer in pi form. When they say leave your answer in the pi form, it's going to be like this one, where you have 3 pi over 4, right? Just leave it. Don't write in terms of what? In terms of decimal, right? Leave it with that pi there. Now let's see, how do you go about it? Now first, convert 60 degrees to radians. Don't forget that, my learners, that when you get your angle in terms of degrees, don't forget to convert it to radians. It's very, very, very important. Okay. Now let's convert it, because we know the formula that we're using, that 60 we're going to multiply by pi over 180 degrees. Then you just press your calculator. Now our angle, it is in terms of what? In terms of radians. In terms of radians, there we can be able to calculate that particular area of a minor circle sector. Then you're going to write a formula that we know to calculate the area of a circle sector, which is 1/2 theta r squared. Now our theta, we can see that we're having the theta, which is pi over 3, right? And then the r, which is the radius. You can see from the picture here, we've got the radius, which is 25 what? 25 millimeter. Then you just substitute your values there, and then the answer that we're going to get is what? Is 625 over 6 pi. But remember, I did not include the units. It's very important to include the units, my learners. This is going to be millimeter squared, right? Millimeter squared. And the previous, the answer that we got, it was in terms of meter. You can see it's very, we have meter squared there. And it's very important always when you calculate the area, you must write the units so that we can be able to see what are you really calculating, right? Because if you just leave your answer with this 231, then it's going to be very difficult to see what are you really calculating. And then even during exam, if you don't put that unit there, you might not get a mark for the answer, right? Because that answer should come with the units. so that we can see that we are calculating the area. So area is always is going to be what? In terms of meter squared, millimeter squared, or centimeter squared. So you should have that squared. All right. Now let's proceed. The question is still continue. Let's see. All right. Number 3, determine the area of the minor circle sector, and then leave the answer in the pi form. We spoke about pi form. In terms of pi form, how is going to be our answer there. Now let us study this picture that we're having. We have the angle there. You can see our angle is 2, meaning if it's 2, it is in terms of radians already. So there is no need for us to convert it, because that 2 is not decrease, right? It's just 2, so meaning it is 2 radians. So we don't have to convert on this one. And then we also have our radius, which is 12 millimeter. Then let's see how do we go about it, how do we calculate it. And then the angle is in radius, we don't need to convert it. Yes, it's true. And then you write the correct formula there, which is 1/2 theta r squared. Our theta is 2, and then radius is 12 squared, and you just press your calculator, then our answer is going to be what? 144 millimeter squared. 144 millimeter squared. But this one, remember, it's a pity that our answer did not give us in terms of what? In terms of pi, right? So that this is the answer that we got. But remember, the units, it must always be there when you are calculating the area. Please, my dear learners. Then the second question, calculate the arc length AB of the circle sector, where you can see this, we are calculating the arc length. The arc length. Remember, earlier on we spoke about arc length. Remember, we spoke about arc length. S. That small s, you remember? So we are going to be calculating that now. This portion here, or this part, or this arc, then we're going to calculate what? The length of that arc, right? Then say round off the answer to 1 decimal place. Now from the picture we are having 80 degrees, and then R, which is 12 centimeter. Now, degrees. Our angle is in terms of degrees. Please, every time when you are dealing with type of questions, make sure that you always convert. It's very important, because if you just continue with this degree, then you are not going to get a correct answer. Now let's see. Convert 80 degrees to radians. Yes, we are now converting. You multiply by pi over 180 there, and then our answer in terms of radians is 4 pi over 9. Then we are happy, we can be able to calculate what? The arc length. But remember the formula, it's very important. It's very important. So every time when you are dealing with these questions, please make sure you do understand which formula to use. Which formula to use. Because we are having so many formula, especially under technical mathematics. So you must be able to know which formula to use, right? But I think it will be much easier if you keep on practicing so that you can get use of this formula, right? Now that is the formula that you're going to use. You remember the formula before it becomes this, it was theta equals to S over R, right? It was what? Theta, let me try to write a theta there. This is theta equals to S over R. That is the formula that we got before. So because we are in need of S, the arc length, then we had to make S the subject of the formula, right? Then this is what we're going to get now. S equals to theta multiplied by radians, which is R. And then the second step, you just substitute there, then you write your answer. Our answer now is 16.8 centimeter, meaning the length of this AB, of this arc length, is 16.8 centimeter. Okay? Now let's proceed. Now we are focusing on what? Segment of a second. We'll be learning on how do you go about segment of a second. Now let's see what is segment of a second. A segment of a second is the area bounded by an arc and a chord. Let me repeat. A segment of a second is the area bounded by an arc and a chord. If you know what is an arc from a second, if you know what is a chord, then you'll be able to understand which part do we say is a segment from a second, right? But we are familiar with arc, we are familiar with chord, right? So that part where you can have an arc and a chord, then you call it a segment. All right, now this is the formula that we're going to use to calculate, for instance, D, they say D is the diameter, the H is the height, right? Then let's see. Now, this is the picture. You can see that we're having a chord there, and then we're having a chord. This is a chord. Let me just show you. This is a chord, and then this is an arc. This is an arc. So this, it forms what? Segment, right? It's segment. All right, let's see what X is equals to the chord length. The chord length, we have a chord there, which is how much? Which is X, right? So you must know if you are giving a value for chord, then you are having X there. And then H is the height of a segment. The height of a segment, I think, is this one. Is this one. From circumference of a second to a chord. So that is the height of a segment. D, of course, we know diameter of a second, we know diameter. So from here, we can just extend this line passing through a center to the next circumference of a second. Maybe this is a center, then we know we have what? We are having a diameter. Let's get example on how do we calculate the segment. Now the first question, it says calculate the diameter of the circle if the chord it is 61,235 millimeter and the height of the minor sector is what? Is 12,4 meter. It's very important to underline what we have so that we can be able to know which one do we need. Remember from our formula there we had D, we had H and X. It's only three elements, which is D, which is diameter, H, which is height, and X, which is the length of what? The length of a chord. The length of a chord. Now we can see that we're having the length of a chord which is 61,235, and also the what? This one of 12,4 millimeters, right? Then let's see how do we go about it. Then you write the correct formula because we are calculating for diameter D. Then you can see that D is already the subject of the formula. So our job is to do what? Is to substitute our values to get the diameter there. And our final answer you can see is 88 millimeter. The diameter is 88 millimeter. So that's how simple it is. Now, the second question, calculate the diameter of a circle if the chord, the length of a chord is 60 millimeter and the height of the minor sector now is 10. The height, the h is 10, right? Calculate the diameter. Right, that is the picture that we're having. Now we write the formula, you substitute, and then you press your calculator, then we are having 100 millimeter. Okay, that's how you should go about it. Now we'll be focusing on what? Measuring the angular and the circumferential velocity. We are going to be measuring or calculating angular and circumferential velocity. Now let us understand what is this angular velocity. What is that? They are saying that angular velocity measures the velocity at the center of a turning wheel or a disc. Angular velocity measures the velocity at the center of a turning wheel or a disc. Right? It is rate at which revolutions measured in radians. Don't forget this, it's very important. Measure in radians are formed. The velocity, the angular velocity, which is this omega, then we're going to use this sine, is measure of how fast the wheel turns. So every time when you come across the sign which is omega, then you know that we are calculating what? The angular velocity. The angular velocity is a measure of the angular displacements per unit of time. All right? Angular velocity, let me repeat it. Angular velocity is a measure of the angular displacement per unit of time. The last point, it says the units for angular velocity are revolutions per second. So every time when you calculate angular velocity, don't forget to write the units. It's very important. Remember earlier on, I also emphasized when we were calculating the area of a sector, I said that it's very important at the end of everything else, write the units. Now in this one, the units that we're going to be using is ref. That's how you should write it in terms of when you want to write it in short, you just write ref per what? Per second, right? Per second. Or you can write radians per second. In short, you can write rad per second. Okay, so that is the unit for angular velocity. So don't forget that when we are dealing with or when we are calculating velocity, don't forget to write the unit of ref per second, or you can use what? Rad per second. Now, this is the formula that we're going to use when we are calculating what? Angular velocity, which is omega equals to what? 2 pi n. Angular velocity equals to 2 pi n. We are familiar with pi. We know what is pi. And then what about n? You can see just down there we have n is the number of revolution per second. The number of revolution per second, right? That is for n. And then this one, we've got another one, when we have to calculate the angular velocity, which is angular velocity equals to what? Theta over time. Theta over t, which is time, right? Then that's the two formula that we are going to use to calculate the angular velocity. Then we are now moving to what? Circumferential or peripheral. We call it circumferential or peripheral velocity. Then they are saying what? Circumferential or peripheral velocity is the speed. Is the speed at the periphery of a circular part due to its rotation. The speed it rotates, right? So this is the formula that we're going to use. V, which is the as peripheral, equals to what? Pi dn. We know pi. What is d? D is the diameter of what? A circular part. D is the diameter, and we talked about it, which is the number of revolutions per second, right? Or you can use what? You can use this formula here, which is what? Circumferential equals to angular velocity multiplied by radius. Radius, right? So please, you must know D. What does D stand for? What does N stand for? It's very important to know that, so that it's going to be easy for you to use this formula. Now let's get an example on how do we calculate angular, or how do we calculate circumferential velocity. They sometimes call it what? Peripheral velocity. Then we have the first question. It says a flywheel is rotating at 10 revolutions per second. Per second, meaning this is the what? This is our capital N. If you remember, earlier on we spoke about N. Then we're having N there already. Determine the angular velocity and round off the answer to 3 decimal place. Now let's see how do we go about it. You write the correct formula for angular velocity. Angular velocity. Remember, we had two formula for angular velocity. The other one, it was saying angular velocity equals to what? A theta over t. You can see don't have any angle there. We don't have any time there. So surely we're not going to use that one, but we can use this one that has what? N. And we said N is what? Is revolution per second, right? Then step number 2, then we're going to substitute N is 10 there. And then our answer is what? 62,832 radian per second. Remember, that's unit. And we also agree that we can use rev per second, right? So that's how you should calculate angular velocity. Second question, generate a pulley or a generator pulley rotate at 3,000 revolutions per minute. Per minute. Remember, earlier on we were talking about N, and this N should be in terms of revolution per second. But in this case, it is given in terms of per minute, right? But as we are working with seconds, right? Then the question says calculate the angular velocity in radius per second, right? It's very clear that our question needs us to calculate angular velocity, but in terms of radians per second. But the problem now we are having what? We're having per minute. But how do we convert that? How do we go about it? Let's see. You can see from the substitution, then N we said is 3,000, but over 60. But why over 60? Remember, per minute, a minute is equals to 60 seconds, right? The 1 minute, meaning per means 1, right? Per means 1. So 1 minute is equals to 60 minutes. I mean 60 seconds. So instead of writing 1 minute, we write 60 seconds, because we are working in terms of seconds in this one. Then our final answer you can see is now 314.2 radians per second, right? The third question, it says a pulley of a machine has a diameter of 900 millimeter and it's rotate at 2000 rev per minute. You can see per minute. Then we have to convert something there. Calculate the speed of the belt passing through a pulley in a meter per second, right? Meter per second. We should now calculate the speed of this in terms of meter per second and round off the answer in the 3 decimal place, right? Meter. But now look at the diameter that we're having. It's not in terms of meter. It is in terms of what? Millimeter. Then we'll have to convert that one as well, because we are being guided by the question. The question needs in terms of meter per second. You first convert the diameter there, and then diameter, remember, if you convert 900 millimeters to meter, then you just divide, right? You just divide with what? With 1000. That is going to give us 0.9 meter. Then we write the formula for circumferential, the speed, right? The speed. You remember when we were talking about circumferential or peripheral velocity, it is very clear that we are now calculating the speed, right? Now we have n, yes. Let's see, which is 2000 over 60. Why 60? Why over 60? Because it is rev per minute. And as we want our answer in terms of seconds, right? So we have to convert 1 minute to seconds. So 1 minute is equals to 60 seconds, right? And then D, our D, which is the diameter, remember it was 900 millimeter, but we want our answer in terms of meters, then we had to convert it to meter, is 0.9. Then our answer now is meter per second, right? So that's how you should calculate. Example 2, we are still on the angular and circumferential velocity there. And then the first question says, a pulley rotates at 660 rev per meter, I mean per minute, right? Sorry, per minute. And the diameter of a pulley is 200 millimeter. One, calculate the angular velocity of a pulley in a radian per what? Per second, not in terms of minutes. Now this, how do you go? You write the correct answer there, but we're going to divide with 60. And we all know why 60, because it is in terms of what? Rev per minute. So minute is equals to 60 seconds. Then you just press your calculator and this is what you're going to get. Very quiet, it's very simple to do that. So converting is very important. So every time when you read your scenario, read it very carefully and see what we have and see what we don't have. All right, first I was supposed to write the second question, which is calculate the circumferential velocity of a pulley in meters, in meters second, and the round of the nearest whole number. Now, remember, it was 660 rev per minute. And then now it is in terms of 12 millimeters, but they want it in terms of meters, not millimeters. Then we had to convert 200 millimeters to meters, which is 0.2 meters. And then you write the formula. And this one also we are going to divide with 60. By now you should know why 60. We are calculating in terms of per seconds, not per minute, right? Then our answer is 7, it's 7, because the question is very clear to say round off to the nearest whole number. So answer is 7 meters per second, right? All right, thank you very much for being with me in this wonderful lesson. Then we can have this activity just to test your knowledge and see which one do you understand, and then you can take it from there. And then this is the message for you for today's lesson. that says our greatest weakness lies in the giving up. The most certain way to succeed is always to try just one more time, right? I thank you.